Hi everybody, I'm Jeff Fiorini, VP of Integrated Solutions at Adams Corp. And today's guest on the podcast is George Killian from Headwall, in from Boston this morning.
Yeah.
So very much appreciate you coming in today. Adams has recently partnered with Headwall, and we wanted to have a conversation today to introduce the marketplace to the technology and talk about the history of why this partnership made sense, but also introduce the marketplace to the technology. There's a lot of questions around hyperspectral imaging in the marketplace right now. I think a lot of it is not necessarily understood, even admittedly by me at times. So I think having you here today is great, and appreciate you coming in.
Well, yeah, thanks for having us. Yeah, hyperspectral imaging is a big SAT word for some, but hopefully we can demystify that today, talk about some applications where it's been successful and where we think it's going.
Great. Yeah, appreciate that. Some background on the subject is, and how this came to be. Carlos Rodriguez, our VP of Engineering, and I were up in Boston in 2022, 4 years ago now, and walked into the Vision Show, and the first booth we stumbled into was you. I don't know if you were there, but it was your booth with this exact demo, and they had tea leaves of the same bags, or the same brand of bag and flavor, but one was organic and one was not. And they put it on the stage, they ran it under, and it could tell the difference between the two, and it colored one, say, green and one red. And we were like, what the heck is that? And two guys who are really in the machine vision world looking at that were like, what the heck did I just see? It was crazy. So from there we saw a few different demos of that, and then they mixed them together on the stage and they could still tell the difference. And we saw another demo that was like salt and sugar and things like that, and Carlos and I were just like blown away. So that led into us reaching out to you guys, and years later now we started this partnership. So a quick question I'll start with for you is what is hyperspectral imaging, and how is it different than traditional, what you would see from Cognex, for example, on the machine vision side?
Well, I appreciate you bringing up those demos because I think they're a great demo to introduce to someone who might be new to the technology. Mm-hmm. At its core, hyperspectral imaging is leveraging traditional spectroscopy, so understanding the chemical information, and traditional imaging, so being able to image something in real time, and being able to get that information and being able to process it downstream. So you mentioned the tea leaves, right? Mm-hmm. Something that's organic and inorganic. How are we able to distinguish those? Well, those have a fundamental chemical difference, just mm-hmm. like salt and sugar. Mm-hmm. But the difference, the struggle, right, with traditional imaging is I'm only getting color information or spatial information. And if they all look the same or they look similar enough, but I know there's a chemical difference, I might struggle with differentiating that with, say, traditional imaging like Cognex cameras or the like. Mm-hmm. And so hyperspectral, we're leveraging that spectroscopy and imaging in real time. Mm-hmm. And so we look for applications where things look the same or similar, mm-hmm. but we know that there's been some sort of chemical change. Yeah,
that's how I've described it to just my sales team, for example, is if you look at things and visually can tell the difference, then that's a great Cognex application. But if you can't visually tell the difference, then that might be something where Headwall or Hyperspectral can look at it and get down to the chemical composition level and tell the difference between two things. So George, getting back into this demo that I did see at the Vision Show, can you walk us through what this is here? Sure. And get into the technology, but also the different ways that we can deploy the technology? Because this stage is great for R&D setups, for example, but I can't deploy this inline for an inline process.
No, you couldn't. And we wouldn't want that either, right? Mm-hmm. Well, let's start. This right here is our MVC near camera on our per-class mirror scanning stage. And it's designed to be a laboratory or at-line scanning system. It's fully integrated in our per-class mirror software. It's utilizing our near camera. So from 900 to 1700 nanometers, some halogen illumination in a stage. This is a great tool for someone to be able to investigate what applications they might be able to deploy for hyperspectral imaging. But once we cross that threshold, we can take this camera or the suite of other cameras that we have covering the full spectral range from UV to infrared. We can put that in line, right? And what does that look like? Well, those cameras have onboard processing that utilize the model that you've developed either in lab or at line, and you can put that on the camera and the edge processing system. And what you're getting then is actuation downstream based off of the chemical information, right? So maybe instead of just looking at one part at a time. You might be looking at a whole conveyor belt of parts going by, and once you've detected a board that maybe doesn't have enough coating or has too much coating, you might divert that downstream to ensure the quality product is going through and not others.
Sure. And what type of lights are we using here? I know my traditional machine vision folks are not using these, so walk us through that.
Yeah, well, Hyperspectral captures 300 different colors, right, in those ranges that we're looking at, which means we need to make sure that all of those colors are well illuminated. For traditional imaging, I'm only looking at 3, so I only need 3 colors, so LEDs are good for me. So for Hyperspectral, normally we deploy halogen-based solutions, but we have providers that provide us with multi-channel LEDs to give us a broadband illumination in the V-near or SWIR range, and we can use that in line or at line as well, just as well as we would use halogen. Yeah.
So when I got home from that vision show, I went and looked at YouTube, of course, and I wanted to look at videos and say, okay, what is hyperspectral imaging? And I saw a good one that resonated with me that was, the individual pixels through the visible and invisible wavelengths comprised into a data cube is a spectral fingerprint, if you want to call it, that makes something very, very unique. Can you explain that in a better way for the audience? That's what worked for me.
Sure, yeah. So to start, when we say data cube, what we really just mean is a stack of a lot of images from a variety of different wavelengths. Well, how does that get us the information that we need? Or how does that help us distinguish different objects? Well, if we think of a monochrome camera, black and white, that gets me some spatial information. I might be able to look at a bunch of apples and see which ones are big or small or shaped appropriately or irregularly. With an RGB camera, I can see which ones are red and green and might get some more color and bruising information there. But how about if I want to figure out if those apples are sweet or have a lot of sugar content, moisture, firm, soft, etc.? Well, I can't do that with an RGB, but with that data cube, right, of all of those bands of wavelengths in that visible or infrared range, I can see those chemical differences, and that's what you mean, that fingerprint, right? I can recognize the fingerprint between a soft, firm, sweet, sour, moist, less moisture, apples in those bunches. And that's what we mean when we say a data cube lets us get the fingerprint of what we're looking at and distinguish them in real time.
Great. And you can have different areas of, let's use food as an example. You can have areas of the food that are still ripe and some areas that are rotten, and you can see all of that in one image.
Yeah, it's every single pixel has got all of that information that we can use to leverage.
And can you walk through, a lot of my customers on the, again, traditional side are used to line scan or area scan and getting into how this operates?
Yeah. So here at Headwall, we make line scanning hyperspectral cameras. That's what we focus on. And the reason why is because the optical components that we design inside give us a higher integrity, we'll say, better higher resolution spectral and higher resolution spatial image than as opposed if we were to make an area scanner. We're using a diffractive grating to take that line of pixels and disperse it into its continuous spectrum at every single pixel, correcting for common things like smile or keystone defects that might interfere with some spectral imaging that some of your customers might be used to from the past.
Okay.
Yeah.
And what it does with that is essentially every individual pixel has the data from every wavelength of what it's reflecting back off of that object, right?
Exactly. So again, this near camera here, every spatial pixel will have a continuous spectra from 900 to 1700 nanometers. And our software per class will then classify it on a per pixel basis based off of the model that you've developed.
Okay. Yeah, I know the audience would love to see a demonstration of this technology and how it works and how do I visualize the software and all that. So we will get into that after the talk here, so you can see a demonstration. And just to walk through the sales process of this, because this is new to a lot of the people in the marketplace. So first and foremost, you would contact your local Adams rep or contact George at Headwall, and we'll provide his contact information as well. And we're going to want to come out there and take a look at what's going on. So seeing is believing. For us, we're very visual people. We want to get out there and see, how is this done today? What are the differences between good and bad? And it may be something that is a fit. So what we want to do to test that is Headwall has a lab up in Boston where we can send samples and they'll run it through the stage here and do some preliminary testing at no charge to just get a proof of concept to say, hey, is this going to work or not? That's assuming it's going to be a quick and easy test. From there, we'll get a report back and then we can go to the customer and say, hey, we're able to see the subtle differences between these two objects, and we go from there. So then Adams will work with the customer to say, hey, this is what technology was used in the lab, and this is how we need to mate that technology with your inline process to make sure that it's seamless and that it works at your place. So some of our folks that are in labs might just use this system, but some folks that are working with inline processing are going to get a camera and they're going to get some lights, and we're going to have to take that software and maybe have an HMI where they can visualize, and then it's, do we tie that back into a PLC, or do we have to stop a conveyor when we see a defect, and we work with you on that. So Adams will provide a turnkey proposal to come in and do the full install, and happy to work with our customers on that, just as we do with traditional machine vision.
Yeah, Hyperspectral is no different. We want to make sure that it works in the lab, and then we work with you and your end users to figure out how to to co-create really the best industrial solution.
Right.
Yeah.
Yeah, and I want to get into that too real quickly, is just that, one of the reasons we did partner with Headwall is that you're a US-based company. Mm-hmm. There are a lot of folks that are in this space. There's not a lot of people in the space to begin with, but the only ones that I found that were US-based, that had a lab here in the US. So some of the folks that we work with in aerospace and defense, they have to work with a US entity, and that's been a great advantage for us in working
Absolutely.
with the contractors that we work with to be able to get this testing done quickly, easy, and seamlessly too, by just signing an NDA with Adams, with Headwall, and then we can work with the products in the lab. One use case that we ran into right off the bat with each other was, I had worked with a customer here in Florida that came to me with a problem years before reaching out to you, and I didn't know how to solve it. What they were trying to do is determine if 8 different RTVs in their process, or epoxies, were cured or not. And I call it the caveman tactic of checking that right now, is to poke it with a stick and go, I think so, but these products that are going out the door have, there's a big impact if they're not cured correctly. So we had reached out to you at that point and sent up samples to Boston, where they tested them in the lab and proved with this kit that the 8 different RTVs could be seen with a very clear difference between when they were cured and not. And at that point we said, this is something that we really need to, work on partnering with these guys, and we've gone down the rabbit hole a little bit. But that use case there alone is just something that I didn't know anything in the industry that could do that prior to looking at that.
Yeah. I mean, if we go back to Chem 101 in our high school class, right, we know when there's some sort of physical change, there's often a chemical change associated with it. So think of those RTVs. Before they're cured, they're in a liquid state. Then maybe we hit them with a UV light, or let them cure at ambient temperature in an oven. But then they get rigid, and there's that chemical change, right? It's changed its structural chemistry. Mm-hmm. Well, we can see that, right? In the near infrared range, we see those changes in absorption and reflectance bands, and we're able to leverage that with our machine learning software to recognize those differences. And so, as you say, from the caveman of poking it, is it sticky? Or even just relying on some experts that have been around it so long that they're just using visual cues to hope that they're right. Mm-hmm. But when you're dealing with high value products, you can't hope. You need to be sure, and you need to trace and track, and be able to go back to a lot and validate that something has been cured appropriately. Mm-hmm. And that's where this technology can come into play. And that's why we work with people like you to make those finalized solutions. Mm-hmm. Yeah,
I appreciate that. And yeah, we're now running into applications that were applications that people came to me in the past and I couldn't solve. Another example of that, we're working with a meat manufacturer that's trying to find foreign objects that might get into the food supply. Obviously, that's a really big deal, and they are able to catch it currently, but they have to do it manually, and then it requires somebody watching it at all times, and then that opens the possibility for an escape to get through. And we've done some early testing to prove that this is able to see any foreign object that might be in that supply. And the way that we can do that is by teaching it what, let's call, meat and fat looks like, and what the conveyor looks like, and then anything else is considered a foreign object, correct?
Yeah, and I think another way to add on to that is not just what it looks like, because that's what we think about when we think of traditional imaging and machine learning and deep learning softwares, but we might even say what it chemically looks like, right? What's that chemical signature of a belt, of fat, of bone, of meat, of fur? And the reason why we want to leverage hyperspectral there as opposed to maybe some traditional imaging is because a lot of those have similar color features and shape features. And if everything's ground up, it's all going to be the same shape and color often. So
I'm glad you said that.
Chemically, they'll be different.
I'm glad you said that. And that's exactly why we couldn't use traditional machine vision is you would have to teach it the examples of every single thing that could come through. But you don't know necessarily what's going to come through. So teach it what's good chemically and see anything else that comes through, stop the conveyor and take a look at what's going on. So thank you for that. That's a great example. And another one that we've just recently come into that seems to be hot is conformal coating on PCB. So I'll let you, since you were just off a meeting and demonstration yesterday, kind of talk about what we've seen so far and the lab testing that's been done at Headwall so far.
Sure. Conformal coating, similar to RTVs, right, in the sense that these are often high value products, and when it comes to inspection, there isn't a traditional vision system that you could do to ensure that there's been uniform coating across an entire PCB. And so where does hyperspectral come into play? Well, even though it's a very thin layer, there's still a chemical difference between a board that's coated versus not coated, and even the consistency of that coating on the board as well. So we leverage our machine learning not just to do a classification, right, coated, not coated. We can even go a step further and make regression-based models where we're saying we can get an estimate on what the coating layer thickness is across that board. That doesn't just do tracing and tracking for ensuring quality. That also can ensure better process, right? I'm seeing consistent degradation of the coating across my entire PCB. Now I can make some modifications to my overall operation and ensure that I've got a good quality. Again, we go back to point spectroscopy could do that, sure, but I'm not going to have a certain person go point by point across an entire PCB. And traditional imaging can't do it, right? Because there's no color difference between those clear, transparent coats that are being applied. Yeah.
Right, and there's probably, to my knowledge, probably 4 different types of conformal coats that can go onto a PCB. So now you can actually not only say, is it coated, is it not coated, is it partially coated, is it too thick or too thin? You can also say that's X, Y, or Z conformal coat composition, based off of what type it is. Now, walk me through how you can tell if something's too thick or too thin, because in my mind, I'm seeing the chemical makeup of that regardless, and it bounces back in a certain way. How is it able to decipher if it's too thick or too thin in a certain area?
Sure. So for the engineers in the chat, we're going to be talking about absorption bands for a second. So if you imagine, right, if I were to spray a conformal coating on a PCB, what's happening on the chemical side is that light is reflecting off that PCB, but that transparent, very thin film is absorbing just a little bit of that light. And as we can measure how much light it's absorbing. And as that light's being returned, as more and more layers are being on, more and more of that light is being absorbed. And so we can see a change in that overall spectra because those absorption and reflectance bands are either increasing or decreasing based off of that concentration.
Okay, great. And so then you could train the model to say, this is what too thin might look like. This is what, let's call it, a perfect range might look like, and this is what too thick looks like, and those will bounce back in a different way.
Yeah, we give, through our per-class mirror software, we give the users the tools to be able to set the parameters for quality metrics. So they might be able to say, okay, this level is too much, this level is too little, and they can get a fully automated solution to give, as you mentioned before, green good, red bad on the board that they're inspecting with our visual system. Yeah.
Okay. Great. And I think we talked about doing the same thing with the epoxies too, where it was like, hey, here's a fresh dispense, here's 25% cured, 50% cured, 75% cured, but now you reached 100% by training the system over time.
Exactly. If you think about that same example I gave before with the transparent films, only this time the spectra isn't getting more intense or less intense, it's actually changing, right, shape overall, and we can use our software to say, all right, at this time when the spectra looks like this, it isn't cured. And at this time, it's been 20, 40, 60 minutes, etc.
Right. Okay. Now, those are a few applications that we've been involved in a short period of time that are applications that our traditional machine vision offering cannot solve. What other applications are you seeing outside of just what you've done with atoms that you think are relevant now, but also what do you think this looks like in 1, 3, 5 years from now?
Yeah, that's a great point. So I think to better understand where hyperspectral is going to be able to go, it's good to take a look at where we've been, right? So you mentioned seeing us a couple of years ago and how great our technology was. But before that, camera technology wasn't going fast enough for what hyperspectral does. If you imagine a traditional camera has got 3 bands of color. Our cameras are getting 300 bands of color.
Right.
That's a lot more data to process. So maybe 10 years ago, those cameras weren't fast enough to be able to keep up with those data rates for something in line or at line for inspection. So as camera technologies get faster, hyperspectral can be leveraged for even more machine vision applications. Where does it go from here? Well, I think that we're hoping to be able to make the process of going from training data to an actual deployment about as easy as things for deep learning, machine learning technologies are these days as well. So when people are used to using, as you mentioned before, something like a Cognex camera and utilizing their machine learning tools, we want to be able to provide end users with the same ability to go from collecting, training, and deploying as quickly as possible.
Right.
You mentioned some applications. I think what's really interesting is, food, as you mentioned before, toxin analysis is a really growing problem. You think of traditional measures of being able to screen just by spot sampling a few things. I think one project we did a few years ago with the USDA was on histamine detection on tuna steaks. Right now, someone's taking a small sample from one steak out of millions, right? And using that histamine level and saying, I guess it's safe, I guess it's not safe. We want to be able to, utilize our software and our cameras to be able to put that in line. So now we're screening 100% of that product as it's going by, as opposed to spot sampling. I'd say pharmaceuticals is a growing one as well. Active pharmaceutical ingredients, maybe the distribution of a pill isn't necessarily uniform. Well, a traditional camera isn't going to be able to solve that, and point spectrometry isn't going to be able to be fast enough. With hyperspectral, we can see the distribution of those different chemicals in the pills themselves. That helps the process for that industry as well.
That's really interesting. There's companies that we work with that do transdermal patches. So think of like just a nicotine patch or something like that. But they'll do it for painkillers and things like that as well. And seeing those inline flat films essentially where you could potentially image this and look at the chemistry throughout, I think would be interesting, and tracing back to how much of what is in each individual patch.
Exactly.
Okay.
Ensuring
and
quality
foreign
and
object detection
consistency
for that matter as well.
Yeah, absolutely. So I think, hyperspectral has been historically used a lot in materials recycling for many, many years now. So that application probably isn't new to anyone that's familiar with hyperspectral, but some of these applications we've mentioned, the RTVs, the PCB inspection, pharmaceuticals, and the growing food toxin, I think, are some of the markets that are really going to be growing a lot over the next couple of years.
Yeah. I think Americans are tuned into the food supply lately, so I think you're going to have a lot of business soon.
Absolutely. We want to make sure that the food we eat is safe, and hyperspectral provides the means to be able to do that as well.
Great.
Yep.
Well, thank you for being with us here today, George. Really excited about the partnership with Adams and Headwall. Really excited for the applications that we've already uncovered, and looking forward to many to come. Yeah,
I agree. Headwall, we're a hyperspectral camera and software provider, and we really focus on that. And so we need people like Adams that can take this technology, and being able to engineer it for an end user to make a fully automated solution is really incredible, and we're really happy to be here and partnering with you guys. So thank you so much.
Great. Thank you, George.
Thanks.